Hi, welcome to my channel, our chemistry class with Mr. Shaka. With today's video, I decided to discuss about alcohols, types of alcohols, and their general reactions, including oxidation reaction. So, to begin with the alcohols, we can categorize them into three types of alcohols. We call these primary, secondary, as well as tertiary alcohols. So alcohols are categorized primary alcohols. So it is that A part and the secondary alcohols at the same time these are can be categorized into tertiary alcohols. So there are three types of alcohols, the primary, secondary and the tertiary. To begin with this the idea, how did we do this classification? So based on this idea is that being categorized with that the OH group is the functional group of the alcohol. If this OH attached carbon is attached to two hydrogen, we call it as a primary alcohol. It is the A category. So our idea is that OH group, which is the functional group of the alcohol, is attached carbon if attached to either one carbon atom from the other side, or else it is that two hydrogen atoms. It is the first category, A part, primary alcohol. At the same time, we can move on to the B category, or this it is the first category, or the A category. This is the B category and the C category. So it is that A category is OH attached carbon directly attached to two hydrogen atoms is the primary alcohol. So that second should be, there should be another carbon atom. So OH attached carbon is directly attached to another one hydrogen only. OH attached carbon directly attached only one hydrogen is the B category. We call it as a secondary alcohols. So our tertiary alcohols, which is the C categories, there are no hydrogens directly attached to the carbon atom which is already attached to OH. It is attached to only carbon atoms, and basically no hydrogen atoms are attached to. With this type is a C type, which become a tertiary alcohol. So that primary, secondary, tertiary alcohols, they are vary depending on the OH attached carbon. This is a functional group in the alcohol. If this attached to two hydrogen primary and the one hydrogen secondary, no hydrogen is tertiary. I have taken two different reactions of the alcohols. Number one with the PCl5 esterification reaction with carboxylic acid or acid chloride. So it should be the esterification has been can be happen basically either with the carboxylic acid, or else it can be with the carboxylic acid or carboxylic acid chloride. So the acid chlorides are all can be able to react with the alcohols to produce the ester. Product is the ester. Both these reactions can undergo easily whether the alcohol is primary, secondary, or tertiary. All alcohols undergo. That's why we can say all alcohols undergo these two reactions. First one with PCl5, second one with esterification. This is the product we call as an ester. Ester has a pleasant fruity smell. So your observations vary. With the PCl5 always it is that observation would be it is the steamy white fumes. Observation would be steamy white fumes because hydrogen chloride gas is generated which produce steamy white fumes. But the esterification, the observation, that is the smell also an observation. It is that always give the pleasant fruity smell. Pleasant fruit like smell is the observation during the esterification. So observation with PCl5 is the white fumes. So we call steamy white fumes. Now I get some examples to see. With PCl5, it's very clear now. PCl5, phosphorus pentchloride, it's very clear now. With the primary alcohol, you can see it is there is that OH attached, carbon is attached to. Obviously, more than two hydrogen in this instance, so it is more than two, but it is having the requirement of two hydrogen. So this is the condition. So that product would be CH3Cl hydrogen chloride gas being released with the primary. Second one, this OH attached carbon is attached to one hydrogen, so it's a secondary, and it also generates the hydrogen chloride gas. Tertiary alcohol, this OH attached carbon is not attached directly to any of the hydrogens, only the carbon atoms. With that, it is, you can see that OH being replaced by now the chlorine. Here OH replaced by the chlorine, OH replaced by the chlorine. So all the three reactions generate hydrogen chloride gas, which is the observation made. Steamy white fumes is the observation with PCl5. Whether it is primary, secondary, tertiary respective, there would be only one common observation. This is the esterification reaction. I had used the methanoic acid, is the carboxylic acid, primary alcohol. So obviously when the carboxylic acid is written in this way, I can't get this ester easily, so I reverse this. So it is the water molecule always goes that way from the OH of the acid as well as it is the hydrogen from alcohol. So obviously there is a gap over here. So it is the carbon oxygen directly attached to this carbon oxygen come from the carboxylic acid, and this would be the ester and the water would be the product. So with the primary alcohol ester is produces, we call it is a methyl methanoate is the name. And the second one again, I'm changing this, so it is much easier for you to write down the formula. So it is that OH is now moving away with this hydrogen. So your product ester should be equals to, this is easier for you to write down the ester product with this one. So it is taking that OH part. So obviously this is attacking to the CO part and the hydrogen. So it is the alcohol and the ester linkage from the secondary alcohol, because carbon attached OH is directly attached to one hydrogen. So it is the tertiary one again, much easier. So I should write down it is the AOH and it is the CO. So it should be that hydrogen part over there. So the water molecule goes away, OH from the carboxylic acid, and with the tertiary alcohol, so this part is lost as a water molecule. So it is that main concern would be this is attached to CO part, which is attached to the hydrogen, so that the ester would be produced in all these primary, secondary, and the tertiary alcohols by losing a water molecule. So we call this is OCO is that ester linkage. So it is that ester has been produced by losing, whether it is primary, secondary, or tertiary. I hope you understood this. The two basic reactions of the alcohol, whatever the alcohol, primary, secondary, or tertiary, it will undergo these two. We are moving on to the oxidation of the alcohols also, which is not all the alcohols are undergoing similarly. We will see the difference. Moving on to the oxidation of alcohols, it is we are first talking about this the oxidation of primary alcohols. So the primary alcohols, example, now you know CH3CH2OH is a primary alcohol, because that the OH attached carbon is attached to two hydrogens. So it is much easier to identify. It's a primary alcohol. The oxidizing agent always potassium dichromate with the presence of some acid we call acidified potassium dichromate. This is usually orange in color. So that primary alcohol will undergo oxidation. It is very often oxidized product would be through that intermediate aldehyde. It would be final product would be that oxidized product would be that carboxylic acid. So it is that we started with this 2 carbon alcohol, which is the ethanol. It is changing into the oxidized product would be turn first into the aldehyde and finally into carboxylic acid. So this is done by this the dichromate. At the end of that, it turns into the green color because dichromate is reduced as it oxidizes the corresponding alcohol. So in this one, if you wish to get the aldehyde out, you should take out this process is the distillation. So as the product aldehyde is formed, it is immediately converted and they remove it from the reaction mixture through this the distillation apparatus. But if you wish to obtain the final product as the carboxylic acid, which is ethanoic acid, that instrument and the apparatus should be heat under reflux, including vertical condenser. So in that condition, alcohol undergo full oxidation. Final product is that carboxylic acid. We started with the 2 carbon, therefore it is 2 carbon carboxylic acid. So whether it is primary or secondary or alcohol oxidation, or whether you do distillation or heat under reflux, it doesn't matter. You would notice the color change orange to green. So this is the oxidation of primary alcohols. We are moving on to see how this the oxidation happens with the secondary alcohol. Oxidation of the secondary alcohol, I have taken OH group attached to carbon is attached to only one hydrogen. I have taken an example. It is that propan-2-ol, and either it is distillation or heat under a reflux or waste, only one product is produced, we call, which is a ketone. In this instance, the ketone is we call produced ketone is propanone. So the propanone can be produced either with the distillation or heat under reflux. That doesn't matter what's the method of doing, but it's advisable to use the heat under reflux instead of distillation because rate of reaction is much faster and higher yield of the product can be obtained with heat under reflux. We move on to tertiary. Oxidation of the tertiary alcohols, they are not oxidized because that tertiary means that OH attached carbon is attached to carbon atom directly and there wouldn't be any hydrogen. Because of that, tertiary alcohols are not oxidized under the conditions where we place with this the orange color potassium dichromate with this acid here, usually dilute sulfuric acid. So you can remember oxidation of primary alcohols is always that two products aldehyde through carboxylic acid, but the secondary one would be the ketone, but tertiary alcohols are not oxidized. So this way you can understand and easy to answer the questions which are usually asking at the examination. I hope you understood this part of the oxidation of alcohols. I hope it would be useful for your examination work. Thank you so much for watching the video. Hope to meet up you soon with another video. Thank you.